All right, let's talk about one of the most powerful, controversial, and strategically important materials on Earth. It's an element that literally defined an entire age of human history, for better and for worse. We're going to break down the very high-stakes world of uranium.
Okay, to really get a sense of what we're dealing with here, just picture this. A single kilogram of uranium, about the weight of a pineapple, can produce the same amount of energy as 1,500 tons of coal. That's not a typo. And that mind-blowing energy density, it's at the very heart of what makes this element so incredible and so unbelievably dangerous.
And this right here, this is the fundamental paradox of uranium, isn't it? On one side, you've got this source of clean, super reliable, low-carbon power that can keep cities humming. But on the other, it's the key ingredient for the most destructive weapons ever conceived. It can build a future, or it can end one in the blink of an eye.
So, that brings us to the big question. The one we're really going to try and tackle here. Is all that power worth the risk? Is uranium a solution we should be embracing for our future? Or is it a Pandora's box that's better left closed?
To even begin to answer that, we've got to go back. We need to look at how we got here in the first place. How did we go from discovering this weird rock to unlocking the immense power hidden deep inside its atoms?
So believe it or not, uranium was actually discovered way back in 1789. But for more than 100 years, it was really just a scientific curiosity. The real game changer? That came in 1938 with the discovery of nuclear fission. And once that happened, things moved fast. I mean, terrifyingly fast. That discovery led directly to the Manhattan Project and the bombs of 1945. And yet, just 6 years later, that very same force was used to generate electricity for the first time.
And here's a detail that I just find amazing. The setting for this world-shattering event. It was so normal. The atomic age didn't start in some top-secret desert lab. It literally began in a squash court under the stands of a university football field. How wild is that? It makes the whole thing feel so much more real.
Okay, so that's the history. But what is it about uranium itself that gives it these unique and, let's be honest, fearsome properties? Let's get into the science just a little bit. Basically, uranium is this incredibly dense heavy metal. But here's the key thing you need to know. It has two main versions, or isotopes. Almost all of it, like 99.3%, is something called U-238. Kind of boring, relatively stable. The real star of the show is that tiny little sliver, that 0.7%, called U-235. That's the fissile stuff. Fissile is just a fancy way of saying you can split its atoms apart. And when you do, boom, you get a massive release of energy.
Okay, but getting to that powerful U-235 isn't easy. It's a whole industrial process. First, you've got to mine the ore and process it into this stuff called yellowcake. Then, that gets turned into a gas, which is kind of wild. And then comes the really tricky part, enrichment. That's where you painstakingly increase the percentage of that useful U-235. Once you've done all that, you can finally make the fuel rods that go into a reactor.
And after all that work, where does it all go? Well, the vast majority, a full 90%, is used for just one thing: nuclear fuel. It's powering around 440 reactors across the globe, giving us about 10% of all the electricity we use. That little bit left over, that goes to the military, medicine, and research.
All right, so we've got this incredible low-carbon energy source. Sounds pretty great, right? Well, as they say, with great power comes great risk. It's time to look at the other side of the uranium coin, the serious radioactive cost.
And yeah, the list of downsides it's a long one. You've got radioactive waste that stays dangerous for like thousands of years. There's the constant worry about proliferation, making sure this stuff doesn't end up in weapons. The mining itself can be pretty rough on the environment. Not to mention, building these plants costs a fortune and takes forever. And then there's the big one, public fear. You just say the words Chernobyl or Fukushima and people get nervous, and for good reason.
Now, when you put it up against renewables, solar and wind, the trade-offs get really stark. Uranium definitely doesn't win any popularity contests, and you can't build a reactor nearly as fast as a solar farm. But, and this is a huge but, it has one massive ace up its sleeve: baseload power. It just works. 24/7. Sun, no sun. Wind, no wind. It's always on.
So we're back to that central dilemma, aren't we? This incredible, unmatched power source versus these really serious long-term risks. How on earth do you balance that equation? How do you figure out what it's really worth?
Well, that's exactly what we're going to do now.
It's time for the verdict. We're going to score uranium across a bunch of different criteria and see where it really lands in the grand scheme of things.
Okay, let's look at the scorecard. Historical impact, a massive 9.5 out of 10. I mean, come on, it kicked off the entire atomic age. That's a no-brainer. Its core properties, a solid 9.0. That energy density is just unmatched. But here's where it starts to stumble. Workability gets a 6.0, and scalability and cost gets a 6.5. Why? Because the whole process is just so complex, so dangerous, and crazy expensive. But, and this is important, its lasting relevance gets a really strong 8.5. With the whole world hunting for clean energy, uranium is back in the conversation big time.
So when you add it all up, when you weigh the pros and the cons, the final verdict for uranium is a high B tier.
And that really makes sense, right? Its power and strategic importance are just off the charts, which keeps it super relevant. But those huge, scary risks, the waste, the weapons, the fear, you just can't get around them. And that's what keeps it out of that A tier or S tier. It's an essential tool for sure, but a profoundly dangerous one.
But hey, just because it's B tier doesn't mean the story's over, not by a long shot. In fact, what's happening next with uranium is maybe the most interesting part of the whole story.
And here's why it's so critical right now, in 2026. For all its problems, uranium is making a comeback, a big one. As we all scramble to find ways to fight climate change, its ability to pump out massive amounts of clean, reliable power has shoved it right back into the spotlight.
And we're not talking about the old-school nuclear plants of the past. There's a genuine wave of innovation going on. You've got these small modular reactors, or SMRs, that are supposed to be way easier and cheaper to deploy. There are new fuel technologies that promise to be safer. And with everyone worried about energy security these days, you're seeing huge new investments from countries all over the world.
And all of this, it leaves us with one last, really big question. We've always known that this incredible power requires an incredible amount of responsibility. So as we stand here potentially on the brink of a new nuclear age, the question we have to ask ourselves is, are we finally ready for it? Are we ready to handle both edges of that sword?